After completing classification, nomenclature and preparation methods of amines, then we will discuss physical properties of amines, in which we will discuss intermolecular forces, boiling points and solubility of amines. Let us see one by one. Intermolecular forces. What are intermolecular forces? Atoms within a molecule are attracted to one another by sharing of electron. This is called as intermolecular forces. The nitrogen-hydrogen bond in amines is a polar. Why it is polar? Because there is a electronegativities of nitrogen, because there is a difference in between electronegativities of nitrogen and hydrogen. Nitrogen is more electronegative than hydrogen. Due to the polar nature of nitrogen-hydrogen bond, primary and secondary amines have intermolecular hydrogen bonding. So what are intermolecular hydrogen bonding? When hydrogen bonding takes place between different molecules of the same or different compounds, it is called as intermolecular hydrogen bonding. Example, alcohol, hydrogen bonding in alcohol, water, ammonia, etc. Okay. The intermolecular hydrogen bonding is greater extent in case of primary amine than in secondary amine. Why? Because in case of primary amines, there are two hydrogen atoms bonded to nitrogen for hydrogen bonding. See this. This is a hydrogen bonding in case of primary amine. Is two hydrogen atom is available for hydrogen bonding. Okay, this is a intermolecular hydrogen bonding in primary amines. Listen carefully. Say this is a hydrogen bonding in primary amines. Tertiary amines do not have intermolecular hydrogen bonding, as there is no hydrogen atom on nitrogen of tertiary amines, because all three hydrogen atom is replaced by three different aryl or alkyl groups. Therefore, tertiary amines do not have intermolecular hydrogen bonding. But due to nitrogen and carbon bonds, tertiary amines are polar molecule. Tertiary amines are polar molecule and have intermolecular dipole-dipole attractive forces. Intermolecular dipole-dipole attractive forces. What is intermolecular dipole forces? Are attractive forces between the positive end of one polar molecule. Thus, intermolecular forces of attractions are strongest. Intermolecular forces of attractions are strongest in case of primary amines and weakest in case of tertiary amines, because there is no any hydrogen atom for the hydrogen bonding in case of tertiary amines. The observed order of boiling points of isomeric amine is listen carefully, observed boiling points of isomeric amine is primary greater than secondary amines greater than tertiary amines, which we will see in the table, serial numbers, first, second and third. It can be explained on the basis of intermolecular forces in them. It can be explained on the basis of intermolecular forces in them. The lower aliphatic amines are gases. First few members of aliphatic amines are gases and having fishy order. There is a special fishy order in case of lower or first few members of amines. Middle members are liquids. Middle members of aliphatic amines are liquids and higher members are solid. Higher members of aliphatic amines are solid under ordinary temperature and pressure condition, or under ordinary temperature and pressure condition. Aniline and other aryl amines are aniline. First member, aniline and other aryl amines are usually colorless. Aniline and other aryl amines are usually colorless liquid but get colored as they are easily oxidized by air. If it is contact with air, then it becomes colored due to oxidation. Due to their ability to form hydrogen bonding with water molecule. Due to their ability to form a hydrogen bonding with water molecule, lower aliphatic amines are soluble in water. First few members or lower aliphatic amines are soluble in water. Solubility of amine decreases. Listen carefully. This is most important point. Solubility of amine decreases with increase in molar mass of amine. Solubility of amine decreases with increase in molar mass of amines due to increase in size of hydrophobic alkyl group. Number of alkyl group increases, solubility decreases. Simply, aromatic amines and higher aliphatic amines are insoluble in water. Okay, this is most important point. Why higher members of aliphatic amines are insoluble in water? Because there is a hydrophobic alkyl groups are present. Aromatic amines and higher aliphatic amines are insoluble in water. So this is a hydrogen bonding between amine and water molecule. See, this is a hydrogen bonding, water molecule, and this is amine, hydrogen bonding. Since nitrogen hydrogen bond in amines are less polar than hydrogen and oxygen bond in alcohol. What is? Since nitrogen hydrogen bond in amines are less polar than oxygen hydrogen bond in alcohol, water solubilities of alcohols, amines and alkanes of comparable molar mass in water are in the decreasing order. See, this is a order, decreasing order. It means that alcohols are more soluble in water than amines than alkanes. The order of boiling points of alkane, amines and alcohols and carboxylic acid of comparable mass. Since nitrogen hydrogen bond in amines are less polar than oxygen hydrogen bond in case of alcohol. Nitrogen hydrogen bond in case of amines are less polar with comparing with the oxygen hydrogen bond in alcohol. Water solubilities of alcohol, amines and alkanes. What about the water solubilities of alcohol, amines and alkanes of comparable molar mass? Means molar mass is same of alcohol, amines and alkanes. Then what is the order? See this order. Alcohols having greater solubility than amines than alkanes. The order of boiling point of alkane, amines, alcohols and carboxylic acid of comparable molar mass is as follows. Alkanes have lower than amines, lower than alcohols and lower than carboxylic acid. This is we will see in the table, next table with the serial number 4, 5, 6 and 7 compound. See, this is at the fourth compound there is a propionic acid. See this propionic acid. Molar mass is 74 and boiling point is 414.4 Kelvin. Then fifth compound is N-butyl alcohol. Fifth compound is N-butyl alcohol. Molar mass is 74. Boiling point is 390.3 Kelvin. And sixth compound is tertiary butyl amine. Sixth compound is tertiary. This is a tertiary butyl amine. Molar mass is 73 and boiling point is 318.5 15 Kelvin. And seventh and last compound is 1,1-dimethyl propane having molar mass 72, but boiling point is 300 and 300.8 Kelvin. So this follows the order: alkanes, amines, alcohols, and carboxylic acid. Okay, have you follow this? The order of boiling points of alkanes, amines, alcohols, carboxylic acid of comparable mass as follows: alkanes lower than amines, then alcohol, then carboxylic acid. Question may be asked on this. This is the most important point. Then we will discuss next an important bit from this topic, that is basicity of amines. Why amines are base? Because on nitrogen atom there is a presence of lone pair of electron on nitrogen atom. In terms of Lewis theory, amines are bases. According to the Lewis theory, amines are bases. Why amines are bases? They can share a lone pair of electron on nitrogen with an electron deficient species. They can share lone pair of electron which is present on nitrogen atom with electron deficient species. For example, trimethylamine shares a lone pair of electron with the electron deficient boron trifluoride. See this reaction. The trimethylamine reacts with electron deficient species boron trifluoride, formation of trimethylamine boron trifluoride. Okay, so this is due to the basicity of amines. Why amines are bases? According to Lewis theory, they can share a lone pair of electrons with an electron deficient species. I hope that all of you follow this. Why amines are bases. The basic strength, another important point, the basic strength of amine. The basic strength of amine is expressed in quantitatively as a Kb and pKb values. Kb and pKb values. In terms of Lorentz-Bonnstein theory, the basic nature of amine explained by writing the following equilibrium. See this equilibrium: amine reacts with water, formation of, see this equilibrium, amine when reacts with water, formation of conjugate acid. In this equilibrium, amine accept proton, hence an amine is a Lorentz-Bonnstein base. For stronger base, this equilibrium shifts. Listen carefully. For those are stronger base, this equilibrium shifts towards right. Thereby the Kb value is larger and pKb value is smaller. Listen carefully. Kb value is larger and pKb value is smaller, and vice versa. Okay, so what is Kb and pKb are used to predict whether a chemical species will donate or accept proton. pK and pKb values, what it gives? It gives to predict whether a chemical species will donate or accept protons, hydrogen cations, at a given pH value. The equilibrium constant indicates basic strength. Equilibrium constant indicates basic strength, and you know that pKa and pKb is equal to 14. So, and describe the level of ionization of base. Okay, so large Kb values, listen carefully, large Kb value means a base has largely dissociated and indicates a strong base. This is most important point. Listen once again what I am saying. A large Kb values, not pKb, yeah? Kb values means base has a largely dissociated and indicates a strong base, and another a small pKb values. Here small pKb values indicates a strong base, while large pKb values indicates a weak base. We'll see in the chart. I hope all of you follow this basic strength of amine, okay, which is expressed in the value of Kb and pKb values. So stronger base having more or large Kb values, but small or lower pKb values. Okay. The difference in electronegativity. The difference in electronegativity between nitrogen and hydrogen atoms. Difference in electronegativity of nitrogen and hydrogen atom in presence of unshared pair of electrons over the nitrogen atom makes amines reactive. Why amines are reactive? Why amines are reactive? The difference in electronegativity between nitrogen and hydrogen atoms and the presence of unshared pair of electrons over the nitrogen atoms and make amine reactive. The number of hydrogen atoms, listen carefully, the number of hydrogen atom attached to the nitrogen atom also decides the course of reaction of amines. How many hydrogen atoms present on nitrogen which decide the course of reaction of amines? Very simple. That is why secondary and tertiary differ in many reactions. Moreover, amines behave as a nucleophile. Amine behave as a nucleophile due to the presence of unshared electron pair. Why amines behave as a nucleophile? Because which have unshared pair of electron on nitrogen. Some of the reaction of amines are described below. Let us see the examples which explain the basic nature of amines. So this is the basic character of amine, in which there is amine when it reacts with hydrochloric or any hydrogen halide, formation of this salt. And in case of aromatic amine, aniline, when reacts with hydrochloric acid, formation of anilinium chloride. The amines or amine salt on treatment with base. This is most important. Listen carefully. What happens when the amine salt treatment with base like NaOH regenerate the parent amine. Very interesting. Amine salt on treatment with base like NaOH regenerate the parent amine. Let us see this reaction. Is a salt which is formed in previous reaction. When it reacts with base, strong base like NaOH, formation of again amine takes place with the removal of water molecules and halogen. Amine salts are soluble in water. Amine salts, listen carefully, the amine salts are soluble in water but insoluble in organic solvent like ether. Amines are soluble in water. Amine salts are soluble in water but insoluble in organic solvent like ether. This reaction is the basis for the separation of amine from the non-basic organic compounds insoluble in water. This property, with the help of this property, we can separate the amine salts from water, from non-basic organic compounds which is insoluble in water, because amine salts are soluble in NaOH. Okay, soluble in water but insoluble in organic solvent like ether. Then see this pKb values is equal to minus logarithm of Kb. Larger, we already discussed this point. Listen carefully once again. Larger the value of Kb or smaller the value of pKb. Larger the value of Kb or smaller the value of pKb, stronger is the base. The pKb values of few amines are given in the table, which we have discussed in the next table. pKb value of ammonia is 4.75 something. Aliphatic amines are stronger bases than ammonia. Why? Due to positive inductive effect of alkyl groups leading to the electron density on the nitrogen atoms. Their pKb values lie in the range of 3 to 4.22. On the other hand, aromatic amines are weaker bases than ammonia. Aromatic amines are weaker bases than ammonia due to electron withdrawing nature of aryl group. Why aromatic amines are weaker bases than ammonia? Because due to electron withdrawing nature of aryl group. Aryl group is a electron withdrawing nature or having electron withdrawing nature. Okay. So this is the chart which gives the different pKb values. On the basis of these values, we can decide the which amine is stronger base or weaker base. As you told that the smaller is the value of pKb, stronger is the base. Okay, those amines having smaller pKb values is a stronger base. Okay, see this reaction. All aromatic amines having the value 9.38, 9.30, 8.92, which is larger than the previous one, because aryl amines are weak bases than the ammonia and primary amines, because pKb value is more. Aromatic amines have pKb values more. Okay, I hope all of you follow this. Then we will discuss the basic strength of amines. Then we will discuss basic strength of aliphatic amines. The trend in observed pKb values from the table and basic strength of primary, secondary and tertiary amines and ammonia can be represented as follows. According to this table, the order of pKb values: more than primary amines, more than secondary amines and less than tertiary amines. The order of basic strength is as follows. Ammonia, order of basic strength of ammonia is less than primary amine, less than secondary amine, and secondary amine having basic strength more than tertiary amine. So then let us see the alkyl amine versus ammonia. Alkyl amine versus ammonia. Let us consider the reaction of an alkanamine or alkyl amines and ammonia with a proton to compare their basicity. Okay. So which alkyl amines are more basic or ammonia, we'll see in this reaction. Due to the electron releasing nature of alkyl group, it pushes electrons towards nitrogen. See this in the first reaction. The electron releasing nature of alkyl group, it pushes the electron towards nitrogen, thus makes the unshared electron pair more available for sharing with the proton of the acid. Moreover, the substituted ammonium ion formed from the amine in the next reaction, the substituted ammonium ion formed from the amine gets stabilized due to dispersal of positive charge by positive inductive effect of alkyl groups. Hence, alkyl amines are, listen carefully, according to the above reaction, hence alkyl amines are stronger bases than ammonia. Thus, the basic nature of aliphatic amine should be increased with increase in their alkyl groups. Okay, have you followed this? Then we will discuss. Thus, as per the observed pKb values of the aliphatic amines, secondary amines are stronger bases. Secondary amines are stronger bases. Basic strength increases as we move from ammonia to primary amine, and from primary amine to secondary amine. But basic strength decreases. Basic strength decreases as we move from secondary to tertiary amine, according to the table. The different values of pKb values are shown in the table. The basic strength and corresponding pKb value depend upon the position of the equilibrium, which is already explained in the previous reaction. The basicity of amine is related to the structural effect which influence the stabilization of various species. Listen carefully. Basicity of amine is related with what? Structural effect which influence the stabilization of various species. Greater is the stabilization, or more is the stabilization of the protonated amine. More is the stabilization of protonated amine, that is conjugated acid. Greater is the basicity of amine. That the protonated amine, that is the conjugated acid, greater is the basicity of amine. You may find some discrepancies while trying to interpret the Kb values of amines on the basis of positive inductive effect and negative inductive effect. Positive inductive effect and negative inductive effect. So what is the inductive effect? You must know. Due to the partial, so first we will discuss the positive inductive effect. Due to the partial displacement of bond pair towards more electronegative atom, polarization of carbon chain takes place, known as inductive effect. It is a permanent effect. It is a weak effect because only partial charge develop. It is operated by only sigma bond. Okay. Then what is positive inductive effect or positive I effect? Simply we may call it as positive I effect. Such atom or group which repels, listen carefully, positive inductive effect. Such atom or group which repels sigma electrons, as compared to hydrogen atoms are positive inductive group, and observed effect is known as positive effect. Okay, and then what is negative inductive effect? Such atom or group which attract, not repel, but which attract sigma electrons as compared to hydrogen atom are negative group, and observed effect is known as minus or negative inductive effect. Okay, so this is the inductive effect and negative inductive effect and positive inductive effect. You may find some discrepancies while trying to interpret the Kb values of amine on the basis of positive inductive effect and negative inductive effect of the substituents present in amines. Besides inductive effect, there are other factors. Not only the inductive effect, but another factor is there. There are other factors like solvation effect, steric hindrance or steric effect, etc., which affect the basic strength. Which things affect the basic strength of amines? Inductive effect, which may be positive, negative, that are, and other effect like solvation effect, steric hindrance, which affect the basic strength of amine. Okay, the structure and basicity relationship of amine. Basicity of amine is related to their structure. Basicity of amine is related to their structure. Basic structure of an amine depend on the age of formation of cation, and structure depend upon the age of formation of cation by accepting a proton from acid. from which acid is obtained, which is obtained from or accept from proton. The more stable the cation, the more stable the cation is relative to the amine, more basic is the amine. More stable cation, more basic is the amine. Okay, then we will discuss the influence of positive inductive effect on stabilization of conjugate acid of aliphatic amine and ammonia can be represented as. So first, ammonia conjugated acid. So first ammonia, then primary amine, then secondary amine and tertiary amines. See this, the stabilization of conjugate acid of aliphatic amines and ammonia. Then we'll discuss the alkyl amines are stronger bases than ammonia. Why alkyl amines are stronger bases than ammonia? So very simple. Why alkyl amines are more or stronger bases than amine? So listen carefully. Alkyl amines, primary, secondary and tertiary are stronger bases than ammonia. Stronger bases than ammonia. This can be explained in terms of electron releasing inductive effect of alkyl group. Which explain this factor? Alkyl amines are strong bases than ammonia. It can be explained in terms of electron releasing inductive effect of alkyl group. As a result, the electron density on nitrogen atom increases. Electron density on nitrogen atom increases, thus they can donate a lone pair of electrons more easily than ammonia. Let us see this ammonia, primary amine, secondary amine and tertiary amine. The electron releasing effect is maximum in case of tertiary amine and minimum in case of primary amine. In gaseous phase is most important here. In gaseous phase, what happens? The electron releasing effect in gaseous phase, electron releasing effect is maximum in case of tertiary amine and minimum in case of primary amine. So this is a trend. See, in gaseous phase, tertiary amine, secondary amine, primary amine and then ammonia. Okay. However, the actual order of basicity in aqueous solution. Listen carefully. What happens in actual condition or actual order of basicity in aqueous solution in case of lower member is to be found as follows. That is most important, which we have already discussed. Secondary amine is in aqueous solution. Secondary amine is having more basic strength than primary, then tertiary amine and then ammonia. But that is, however, alkyl group is bigger. Alkyl group is bigger than methyl group. What happens? What happens when alkyl group is bigger than methyl group? That is ethyl, propyl, etc. There will be some steric hindrance. What happens in case of alkyl group which is bigger than the methyl? Example, ethyl, propyl, butyl, etc. There will be some steric hindrance or steric effect to hydrogen bonding. As a result, the stability due to positive inductive effect predominates over the stability due to hydrogen bond. Hence, tertiary amine become more basic than primary. In other words, overall decreasing strength of ethylamine in aqueous medium is as follows. Okay, secondary or dimethyl in series. This is a dimethyl amine, secondary amine is having more basic than triethylamine, than ethylamine, primary amine. Secondary is more basic than tertiary, than primary. In fact, the basic strength in aqueous solution, listen carefully, in fact, the basic strength in aqueous solution depends only upon the electron releasing effect, but also upon the sterification and hydration effect or solvation effect, which we will discuss next. An alkyl group exert electron releasing inductive effect, which I have already discussed. Inductive effect, positive inductive effect, which stabilizes the positive charge on atom bonded to it. As we move from conjugate acid to ammonia to that of tertiary amine, the number of alkyl group bonded to nitrogen goes on increasing steadily. This results in increasing the stabilization of conjugate acid, and thereby an increasing the order of basic strength is expected. This is the order of stabilization. See, ammonium radical is less than primary, then secondary, then tertiary, and expected order is NH3 is less than primary amine, then secondary amine, then tertiary amine. The expected order of basic strength on the basis of positive inductive effect, which we have already discussed, but listen again. What happens? The expected order of basic strength on the basis of positive inductive effect differ from the observed. It is seen that the observed increasing basic strength from ammonia to amine, from primary to secondary, it is explained on the basis of increased stabilization of conjugated acid. Okay. However, decrease the basic strength of tertiary amine implies that the conjugate acid of tertiary amine is less stabilized, even though the positive inductive effect of 3 alkyl groups in tertiary amine is expected to be a large. This is suggestive of existence of another influencing factor, which is stabilization of conjugate acid of amines. The influence of solvation, which influence of solvation or hydration effect. Influence of solvation, or we may call it as hydration effect by water on stabilization of conjugate acid of aliphatic amines and ammonia can be represented as. Okay. So ammonia with water, and this is a primary amine with water. This is a secondary amine, and this is tertiary amine. The solvent water stabilizes. The solvent water stabilizes the conjugated acid. The solvent water stabilizes the conjugate acid by hydrogen bonding through hydrogen bond to the nitrogen. The number of hydrogen atoms bonded to nitrogen decreases from 4th in NH4 to 1 in NH3 tertiary amine. As a result, ammonium radical is the best stabilized by solvation, while the stabilization of solvation is very poor in tertiary amine. Hydration effect, solvation energy, or same hydration effect. It is also depend upon the stability of conjugated acid. Let's see once again. It also depend upon the stability of conjugated acid formed by accepting a proton from the solution. The hydration effect refers to the stabilization of protonated amine by water molecule. The water molecule forms hydrogen bonding with protonated amine and release energy, which is called as hydration energy. Now, greater the extent of hydrogen bonding in protonated amine, listen carefully, what? Greater the extent of hydrogen bonding in protonated amine, more will be its stabilization. That is, primary amine is more stable since it has three hydrogen atom which can form hydrogen bond with water, and greater will be the basic strength of corresponding amine. The secondary amine is less stable since it has only two hydrogen atom. Less hydration takes place in this case, while that of in tertiary amine is least basic, that it has only one hydrogen atom. Least hydration takes place, which can form hydrogen bond with water. Therefore, the basic strength of amine in aqueous solution should be as follows. कशी व्हायला पाहिजे? Primary amine is greater than secondary than tertiary. Thus, it was observed that tertiary amine is least stable. While it has maximum inductive effect. In case of tertiary amine. And primary amine is most stable. In spite the minimum positive inductive effect. In primary amine, the positive inductive effect is minimum and maximum in case of tertiary amine. In actual practice, what happened in actual? These two opposing factors, listen carefully, very interesting here, and which gives the different answer of the different questions. In actual practice, what happens? These two opposing factors balance each other. In case of secondary amine. This makes the amine to be still more basic than primary amine. Hence, it may be concluded that, from the all above discussion, we can conclude here it is a combination of electron releasing group, hydrogen bonding, and steric effect or steric hindrance or steric factor that determine the stability of ammonium cation in solution, and thereby resulting in the basic strength order of aliphatic amine is like this. Secondary is more basic than tertiary and then primary. I hope all of you follow this. Why? All of you follow this, the order of basic strength of aliphatic amines. Why secondary amine is more than primary? Why secondary amine is more basic than tertiary amine than primary? On the basis of this explanation, we can easily answer this question. Okay, then we will discuss the combined influence of positive inductive effect and solvation on stabilization if conjugate acid of aliphatic amine decide the observed basic strength and pKb values. These two influencing factors, which are those? Solvation and inductive effect. These two influencing factors operate in opposite direction. See this, solvation increase from right to left and positive inductive effect increases from left to right, from ammonium radical NH4 from NH4 to R3NH, that is tertiary amines. Okay, so solvation increases from right to left and positive inductive effect increases from left to right. This is a combined influence of a positive inductive effect and solvation on stabilization if conjugated acid of aliphatic amine decides the observed basic strength and pKb values. The net result is that we already discussed. The net result is that we move from ammonia to primary amine to secondary amine. The basic strength increases due to better stabilization of corresponding conjugated acid, but tertiary amine is weaker base than secondary amine because the stabilization of conjugated acid of tertiary amine by solvation is very poor. The reason behind it. Okay, So this is all about the why secondary amine is more basic than uh, tertiary amine and primary amine. So after discussing the basicity of alkyl amines, then we will discuss basicity of aryl amines. From the pKb values, we understand that aryl amines in general are weaker bases than ammonia and aliphatic amines. The strength of aryl amine is explained in accordance with the Lorentz-Bonnstein theory by writing the following equilibrium, in which aniline is reacts with water, formation of conjugate acid, that is anilinium ion takes place. Here both species, base and conjugate acid, are resonance stabilized but to a different extent. In aryl amines, the NH2 group is attached directly to aromatic ring. Amino group is directly attached to the aromatic ring. The lone pair of electron on nitrogen, there is a lone pair of electron present on nitrogen, is conjugated to the aromatic ring. Is conjugated which? To the aromatic ring. Is less available for protonation. Aniline is resonance stabilized by the following 5 resonating structures. See these 5 resonating structures of aniline. This is the first resonating structure. This is second, third, fourth and fifth. So due to this 5 resonating structure, our aniline is resonance stabilized by this following 5 resonating structures. On the other hand, anilinium ion obtained by accepting a proton does not have lone pair of electron on nitrogen. In case of anilinium ion, there is absence of lone pair of electron on nitrogen. Hence, it can be stabilized only 2 resonance structures. In case of aniline, there are 5 different resonating structures, but in case of anilinium ion, there is only 2. Listen carefully, there is only 2 resonating structures, and therefore less stabilized than aniline. As a result, the equilibrium is shifted towards left. This makes aniline and also other aryl amines weaker bases than aliphatic amines and ammonia. So up to this we have finished the basicity of alkyl amines, basicity of aryl amines. Up to this there are different questions asked on this bit, like let us see the sample question. Write the order of basicity of aliphatic alkyl amine in gaseous phase. Second, why primary aliphatic amines stronger bases than ammonia? Next question, arrange the following amines in increasing order of their pKb values, which can be shown in chart. Okay, so after completing the important bit up to this, these questions are asked on this bit. Okay, next, amines having boiling points. Amines have boiling points higher than the hydrocarbon. Amines have boiling points higher than the hydrocarbon but lower than the alcohol of comparable masses. Explain. This question may be asked for 2 marks. Then next question, explain the basic nature of amine. Write equation to show basic nature of amine. This is also asked for 2 marks. Aliphatic amine is stronger base than ammonia, and aniline is less basic than ammonia, which we have already discussed. So on the basis of this discussion, we can easily answer these questions. Okay, then we will discuss next bit.